Welcome to Masters of Engineering podcast. I'm John Hirschtek. I'm the general manager of the Onshape business here at PTC. I've worked in the CAD business for over 40 years, and I love building CAD software. But the best part of my job is I get to meet some of the coolest product designers on the planet. And in this podcast, you get to meet them too. So very excited today. I have a really wonderful guest. He's Joshua Pope. He's the co-founder and CEO of Trajekt Sports. And Trajekt is the developer of the world's first intelligent baseball pitching machine. I've seen and used pitching machines my whole life, but they tend to throw just straight, simple fastballs. Cool thing is Joshua's machine, the Trajekt Arc, it actually simulates real pitches from real baseball pitchers. Unbelievable. Joshua, welcome to the podcast.
Thanks so much for having me on. I mean, I recently started listening to your podcast, and I'm amongst some really, really awesome engineers who've built some amazing stuff. So just an honor to be called here.
Well, thank you. Well, you deserve it, because I always say that the slogan of my podcast is cool products, the people who develop them, and how they do it. Those are the three things we're trying to learn about here. So I want to jump right in. And first of all, I have to let you know, I'm a huge baseball fan. I grew up rooting for the Chicago Cubs. Now I'm a Red Sox fan. I go to minor league games. I've been all over. I love baseball. I want you to start by telling me about what this Trajekt Arc is.
In high school, I played a whole bunch of sports: hockey, soccer, tennis, and baseball. And we were sitting around a table one day, me and some high school friends, and we're like, all right, we see these games, we watch baseball, we all watch the Jays, and at the time it was Stroman who was our ace, and we could see these trajectories on the screen. Like, you could see how far a home run was hit, you could see the trajectory of every pitch, and we're like, okay, obviously there's a lot of data being collected in baseball, and because we could see these trajectories, there must be information about these pitches. And so the question came up, like, why is there no machine that you can just program in Marcus Stroman and practice against him? Mm-hmm. And so from the moment I left high school, which was in 2014, to when I graduated the University of Waterloo in 2019, my goal was to leverage that existing data and build a product, which we now call the Trajekt Arc, that could replicate any tracked pitch. And for us, it started at the MLB level. But obviously it can trickle all the way down to youth baseball as well.
And so you mentioned that you use real data about real pitches. Can you say, I know if there's anything confidential, obviously you're not going to say it, but can you talk more about where you get that data?
Sure. So there are a bunch of technologies that exist for tracking batted ball and tracking pitches. And so the common pitch tracking technologies are Yakkertech, Rapsodo, who we're partnered with, TrackMan, and Hawkeye. So TrackMan was adopted by the MLB in 2014. So every pitch from 2014 to 2019 was tracked using an MLB-owned TrackMan device, and this data was made publicly available, granted for non-commercial use, to anyone on the internet. And so the MLB teams could leverage that data for trade decisions, for player evaluation, and the MLB teams themselves had the license to this data, but they also made it publicly available to see what analysis and analytics the public could come up with looking at the same data. So we downloaded that data, and some of the initial proof of concept was to figure out, does the data exist such that if you want to build a machine, you have what you need to program it to replicate the pitches? And so those input characteristics is what we call it, or the launch conditions of the ball, need to be made available, or you need to be able to track those things in order for this machine to be useful. And so that's what we had to determine. Could you determine the release position, the release velocity, the release spin vector, as well as the ball's orientation from the tracking technologies? And if you could determine those things, all you had to do was build a machine that controlled those 12 degrees of freedom. There's 4 of them, and they're all in 3-dimensional space.
Wow, that's all there is, huh? No, that's
Just
amazing.
12, just
You
12. Yeah.
you mentioned ball orientation. I happen to have a baseball. I don't have it for this recording. I have it on my desk all the time. You mean literally and this would make sense to me as a baseball fan, the orientation of the ball, like in terms of, whether it's a two seam fastball, meaning the ball would be oriented right like this, or a four seam like this. Is that what you mean? You actually track that?
Yeah. So we actually don't build any tracking technologies or sell any tracking
Yeah,
technologies,
right.
but Hawkeye, which is a camera-based system, they are able to track the seams of the ball as
Wow.
it travels over time. And
Wow.
so,
I was
and so,
prepared
yeah,
with you to talk about spin rate, but you actually can simulate the orient. So will the traject orient the ball the
yeah.
same way as it comes out of a pitcher's hand?
So to get a feel for
Yeah.
the machine, there's this ball hopper at the back, and you drop in 120 balls, and there's a carousel. The carousel drops one ball in at a time, and then it actually stops the ball in this what we call the ball inserter system, which is three belts. And there's a camera. The camera takes a picture of the ball. It identifies the locations of the seams as it randomly dropped in from the hopper, and then reconfigures it into the desired
Oh,
orientation.
wow.
So as you said, two seam for two seam and four seam for four seam. But there's obviously a million permutations in
Sure,
between
they're
them.
they're literally
Yeah.
oh, so you actually get like again, I'd done a little homework and I knew we were going to talk about spin rate and I want to get to release point with you. That's very interesting to me to think about. And again, there's no traditional pitching machine that does anything like this, right?
So existing machines on the market can control up to 5 degrees of freedom.
Mm.
You can normally set the velocity and the two-dimensional spin axis. So the big
Okay.
novelty is that actually got us starting on the project altogether was gyro spin. No machines in the market at the time when we started could control gyro spin, and that's spin in the direction of
Uh,
travel. And this was thought to for a long time to not be important because uh, for any of the people listening who have a physics background, normally the trajectory of the ball is only affected by the Magnus force, which is spin in the plane perpendicular to travel. So that's your backspin and side spin. But the gyro spin, like the spin a bullet has, is just to stabilize the trajectory. And so you'll see footballs are thrown with pure gyro
oh
spin.
yeah,
Bullets
yeah.
are shot with pure gyro spin or rifle spin, as they call it. And so for a long time, this was thought to be sufficient because the gyro spin just stabilizes the trajectory. It doesn't actually create movement.
Okay.
But in 2020, as we were building out our machine, Barton Smith from USU was doing some aerodynamics research on baseballs, and he figured out that the roughness on the ball, because the ball has seams, it's not a perfect sphere. There can be asymmetries. So you could have a spin axis that's going through a very smooth part of the baseball, and if that's on one side of the aerodynamic flow throughout the trajectory, it's going to have a different lift and drag coefficient than the other side of the ball. And so
Hmm.
that difference in wake creation as the ball flies through the air can actually cause balls to move that either can be combined with the Magnus force or can detract from the Magnus force. And so that's how some pitchers actually can create additional movement beyond what's created from just the spin rate.
Wow.
Yeah.
Yeah, that is just this is already so cool. I mean, especially if you're a fan. So so tell me the experience of using it. What do I see if I'm a batter and I stand up? You know, what exactly happens?
So what we do, and with our Trajekt Arc, we're selling our technology to teams that actually have a license to the MLB data.
Okay.
All of our 7 club partners are MLB teams. We are looking at the collegiate market as well, and the collegiate market would have access to their own data. But effectively, what happens is the operator of the machine would take a sample set of pitchers that they want to replicate, and they would upload that to our portal. And on our portal, we would leverage that tracked pitch data, and we would extract the ball release conditions. So that's the release vector, velocity vector at release, the spin axis and spin rate, the ball's release position. So, if you're a tall righty, the machine needs to go to that exact release slot, and the ball's orientation. It'll automatically perform that extraction of those machine parameters. It'll send the command to the machine, and the machine will physically move to that tall righty position. It'll configure the wheel speeds all simultaneously. It'll drop a ball in, get it to the correct orientation. And once it's ready, it'll notify whoever is, manning the computer that controls the machine that your pitch is ready to fire. And so once you click that button, there's a sound like a beep. And what happens is the video, there's a projector that's also sold with our product that sits about 15 feet away from the machine. And the machine's about 55 feet away from home plate. And the projector knows exactly where the machine is. The projector knows you're trying to simulate a tall righty, and it'll display whatever video you upload. So we provide generic video with our machine. So just, collegiate righties and lefties that we have the rights to. But if MLB teams already have their own video that they want to upload, what we're seeing a lot of times is you're pairing the pitch data and the video data with the correct pitcher that you're facing, and you could actually see their wind up before the game.
Yeah. And so you're saying that, like, hypothetically, I know you can't name which teams. I'm very interested that you said 7 major league teams, but you can't name which teams. But hypothetically, this is like, Vlad Guerrero Jr. can step in and simulate hitting Justin Verlander or something, throwing real Justin Verlander pitches. I mean, to me, this would seem like a breakthrough for training a batter. What kind of results are you getting?
Yeah, so it's a really good question. Obviously, as a data focused company, we want to track players' performance, which players are using the machine, how often they're using it, and how does that translate from the training environment to the game. And so we've started along that path. This is also stepping into this space where, because we're working with MLB teams, that data is highly proprietary to each club. But anecdotally, we've heard some really, really awesome stories. There's a specific club who got our machine earlier this season, sometime in April, and they had a player see 30 sliders against an opponent pitcher before the game. And I guess the pitch prediction for that player was that he's probably going to see a lot of sliders. And his first pitch, sure enough, he got a slider, and he hit a single off of it. It was just a single, but everyone had watched this player on the club see the machine and see this pitch type before the game. And he obviously said, yeah, of course it was a slider. And so the next game, the story was that all 9 guys were lining up to use the machine before the game. So that was an awesome one. We've heard similar anecdotes about, specific pitchers have a timing sequence with their leg kick can be really different. And when you upload that pitcher's video in conjunction with their pitch data to the machine, you really get a feel for that windup. And obviously you can upload for videos from the windup or the stretch. And so the team really felt that they had an advantage because of whatever, leg kick or hitch that player has before the game. They're able to visualize and see it. And it's one thing to see it on your computer, but it's another thing to see it, the lifelike size of the pitcher, all timed up with, the exact trajectory of a pitch that he would have thrown in game on a previous day.
Yeah, I get it. In fact, I once met Rich Hill and had a brief discussion with him, who's now a pitcher for the Red Sox. He's been around a long time, and he talks about changing that deliberately during an at-bat, even varying his timing, and even, I think, I don't want to speak too definitively, but certainly his timing and somewhat his delivery mechanics, release angle, things like that, to confuse hitters. So there's real stories. You must find it very cool to be around all these professional ball players.
Yeah, a little bit starstruck at first, right? I'm 4 years out of college, so I'm still around the player's age. And it's pretty cool to see some of these guys. They're on $40 million contracts, and they're around the dugout or they're around the clubhouse, and they're getting a workout in, and there's like, oh, that's really cool. What is that? And they come and they peek their head in during an installation. We get to meet them. So
That's cool.
yeah, it's still a little bit you're a little bit starstruck on that first time meeting, an all-star or whoever it may be, but now it's kind of become par for the course. These are our clients that we're building product for, and so it's more of like, hey, how can we make this better? How do you envision yourself using it?
Mhm.
What do you think so far while you're using it? How real does it feel? And it becomes business pretty quickly thereafter.
And so let me turn a little bit to how you built it. You talked about why you built it, how you came with the idea. Are there any particular design challenges? What would you say is like the biggest design challenge you've had?
So the way we designed the system was sub-component at a time. So the first thing we
Hmm.
did was the gyro spin. Then once we had the gyro spin, we're like, okay, we need to control the ball's orientation. And so we actually made a very simple handheld device where you put the ball into a linear actuator that has, 3 teeth coming out, and you could choose a specific orientation, and it would just deliver the ball to the wheels. It's a wheel-based system. And so that was our first prototype of the ball inserter, but we knew we wanted to make it automated so that you don't need someone dropping a ball in and choosing the orientation. You can drop in 100 balls and you can go hit those 100 balls in your practice session. It would be a little bit cumbersome for a coach to stand back there and by hand choose the orientation. And so
Yeah, I would say
we,
so.
yeah, I mean, that's what currently happens with these three-wheel pitching machines. You have a
Oh,
coach
really?
behind the machine and they drop a ball in, and if you want a two seam, you try to drop it in the two seam way. If you want a four seam, you try to drop it in the four
Oh,
seam way.
gosh.
But you can't capture the precision of a professional Major League Baseball pitcher that way. And so the ball inserter subsystem is a system that probably took us 12 iterations to get right.
Oh, wow. Okay.
So MLB baseballs are actually made with quite high precision, but I think there's like a 0.2 inch circumference tolerance that is acceptable. And because there is some compliance in ball size, you need to have a conveyor system that doesn't bind when you have a large ball and can still grip onto the smaller balls. And
Hmm.
so finding the perfect belt configuration that provided enough tension to that range of ball diameters was extremely challenging, and it propagated some downstream effects. So the first machine we delivered was last spring training in 2020. And it was a prototype unit that we sent down to an early adopting club to get their feedback. They ended up really liking it, and they leased the product. And fortunately, they've got actually another 2 machines from us. They've leased another 2 machines since that initial
Wow.
prototype day. One for their main stadium and one for a AAA facility. But one of the problems with not having that ball inserter system robust and adaptable to all those ball sizes was that you need to deliver the ball at a precise time that matches up with the frame in the video. Because if you deliver the ball too early, the pitcher hasn't thrown based on the video yet. And if you're
Oh,
too late, it looks like the balls should have come out already. And so what we noticed with that early prototype that was in the field was that about 1 in 20 pitches, there was a binding issue with the belts, or the ball was too small and it wasn't delivering repeatably the ball to the
oh,
wheels.
yeah,
So that was a
yeah.
system that we spent, I would say, over a year and a half, maybe 2 years on
Oh, wow.
perfecting. And that was
Wow.
11 different prototypes, changing all
Wow.
the belt configurations. We actually ended up going with a custom made belt. So that's how that went down.
I know that in college you did co-ops in like facial surgery, electrophysiology of brain, right? Were there any lessons that you got from your biomedical background that helped you? I mean, I can't map that here, but I just thought I'd ask.
Yeah, definitely.
Oh, really?
My co-op experiences were quite interesting. Um, I started in the research space at a hospital doing neurophysiology research. I had a strong interest in the brain and how it works.
Ah,
And that was kind of related to to the product. I like to think of myself as really trying to deeply understand how the brain works, how we learn. And so obviously there's the whole theory of, practice makes perfect. And if you see something enough times, your brain's going to adapt. But one of the things I learned through that research is that our brains are really these pattern matching machines. And so the idea with and the way it's related to Trajekt is that the more times you see a given pitcher, the better your performance is. And so there's this notion in baseball, the times to the order effect. And the third time at bat, once you've seen, 6, 7, 8, 9 pitches from an opponent pitcher, the batting average increases. And you can remove the effects of fatigue, and you can see that this holds true. And so the idea with Trajekt is, could we leverage how we understand the brain to work and learn and create a machine that could precisely replicate the optical stimulus? So what is the optical stimulus of a baseball player when they get up to bat? It's the whole interaction of the opponent pitcher's biomechanics. It's the motion blur of the ball. So there's about 400 milliseconds between release and when it crosses the plate. And certain pitches will have a certain motion blur. So for example, on sliders, oftentimes you can pick up a red dot of the seams because of the spin axis, the ball's orientation, and how that appears to the batter. And so no other pitching machine was replicating that optical stimulus of what it's like to be at bat.
Wow.
And so I think that co-op that I had and doing some neurophysiology research was the big aha moment of, hey, that 2015 conversation in high school about wouldn't it be cool if I could hit against Stroman is like, that's a serious technique for improving elite athlete performance.
That's so interesting. I'm so glad I asked, because I wouldn't have thought about that. You're trying to recreate, obviously, the visual. It's interesting to me also because my wife is a brain scientist. In fact, she's the outgoing chair of the Organization for Human Brain Mapping and is a professor in research, doing research on generally using things like medical scanning technology to understand how brains work. And I won't go too far into it, but she got into the field because she was a photographer and was trying to figure out how come her camera can never create what her eyes see exactly. And it reminds me a little. Let me go. I'm going to run out of time. A million things I wanted to ask you about. The technology in general with baseball. First of all, who's winning the tech war right now between baseball pitchers and baseball hitters?
Yeah, so to answer the first part of your question, I think that there was a heavy favor for technology used for pitch design and helping pitchers, and there wasn't a product that leveraged that same data for batters. So really, we're just trying to even the scales.
You're evening the score a little bit between.
Yeah, but on the other hand,
go offense, because us fans we don't want so many strikeouts. We want to see more hits. Yeah. So okay.
Yeah, exactly. Yeah. And so there is still an application for pitchers with our product, and a lot of times when we install these machines, you have 4 or 5 starters asking, hey, can I see myself on the machine? I've never stood into my fastball or my curveball or my slider. I'd like to stand in. So they do that for fun. But then on a more serious note, you can play around with the launch conditions to see how you could change your pitches to create more movement. And so one thing that teams are trying to do is you'd program in your starter's fastball or slider. And what happens if you just change that launch, the release orientation by 10 degrees, by 20 degrees, by 30 degrees? What happens if they start with the ball slightly differently in their hand? They throw the pitch the same way to create the same, 3-dimensional spin axis, but you just change the ball's orientation. Can you find an orientation that creates more vertical or horizontal movement, which is the deceptive part of pitches, where they actually move relative to the trajectory of gravity?
This is I gotta say, this is so cool, hearing all these different dimensions to it. Speaking of cool, by the way, I wanted to touch on your product is cool and different. What about your process of design? As a product developer and manufacturer, you make the machines yourself.
Yes.
Is your process different than a lot of other designers? Some of our listeners, would you say you've innovated there too, or is it pretty much like other firms?
Yeah, so I mean, I wish Rowan was on the call. He's our CTO. He definitely has spearheaded the a lot of the prototyping. He's an expert coder. He's written a lot of our code source, and he's also spearheading the manufacturing process. We manufacture our machines locally out of a machine shop in Mississauga.
Mhm.
And we have a really close relationship with our manufacturers. And oftentimes we actually just work out of a joint space with them during that manufacturing process. And so, we're a startup. We're 7 people right now, and we have the ability to work really close with our manufacturers so that as COVID affects the lead time of certain electrical parts, like we use industrial PCs, we use high-speed cameras,
Mhm.
we use about 12 servo motors. So some of these parts during COVID were pretty challenging to find, and just being able to work really closely with our manufacturing partner to swap out similar products during these manufacturing phases and changing the interfaces for some of these motors was kind of critical to get our product out the door in the time frame that we needed to, because the season starts mid-April, and we had commitments to 7 clubs to deliver those machines.
Do you have to be a pro? Do you have to be a elite player to take a few swings, or are your machines going to become available to high schools, or even can I go to an amusement park or a baseball academy place like where I took my son for many years? Will I be able to step in and do that anytime soon?
Yeah, I think that's our next plan of market penetration. Obviously, developing our reputation at the MLB level helps us prove the efficacy of the device and show really how amazing it can be and why precision pitch replication matters. But if we can take the best features of it, like the video component, the dynamic release, and build out a product that's more affordable, that can be sold to recreational facilities, player development facilities, other batting cages internationally. That's something we are actively pursuing, and the more people that can get in front of the machine, the better. Because I think like there is that entertainment value.
Yeah.
I even think like it would be awesome to talk to MLB about having some of these machines at stadiums, so like you can really
Uh-huh.
appreciate the skill of these pitchers, right? And I think
Yep.
I've developed a newfound appreciation for MLB quality pitching. Like I've stood in against the machine against 20, 30, 40 fastballs, and just making very poor contact either A stings your hands, or
Yeah.
B is super far few and far between. So it takes me
Okay.
about 40 swings against a 90-mile-per-hour fastball to square one up. So
Against a 90 mile per hour fastball, which is different than 95 or 98 or whatever. But
exactly.
wow, well, at least you get plenty of chances to practice. And so, one final question. Look out 10, 20 years from now. Do you think the impact of technology in baseball, pitching, hitting, sports world in general, other sports, do you think that tech like yours is going to cause some discontinuous change in the sports scene?
Yeah, it's a super interesting question. I mean, one of the goals at Trajekt is to push the boundaries of human performance and figure out like what is that upper bound? How good can humans become at hitting 95-mile-per-hour balls with various types of spin? Um, and so our goal is to continuously develop technology that gets us closer and closer, and figure out, is there a limit to what humans can do, or with the aid of technology, are we kind of can continue to learn and adapt and get better? So eventually, I suppose technology will be so good that uh, if you train with a certain device, you reach this like threshold of skill where your brain has learned everything it needs to
Yeah.
learn. But I think we're still quite far away from that saturation point. The human
Okay.
brain's incredible.
Well, I could talk to you all day. I'm hoping to meet you in person and maybe take a swing myself. That would be a great thrill. Um, I just want to thank you, Joshua, for taking the time to join us, share the story, and to our listeners and viewers, I want to thank you all for tuning in. And you can learn more about Trajekt, about Josh's company, Trajekt, at trajectsports.com, TRAJEKT sports, SPORTS.com. And also they have Instagram and Twitter feeds at Trajekt Sports, same spelling, at Trajekt Sports. Or better yet, Josh tells me you can come in for a demo in Toronto. I'm guessing that's if you're a major league team or maybe a college program, like not a regular guy, a regular batter off the street, right? But
Well, you never know. You never know.
okay,
We might open it
okay,
up to the public if there's enough interest.
yeah.
Once we get those demos out of the way, for sure. Yeah.
Yeah, but that's great. And it's good to know that people can really see it. It's not just a theory idea. And I want to let our listeners know you can listen to other episodes of Masters of Engineering or subscribe at Apple Podcasts, Google Play, Spotify, or wherever you find your podcasts. Also, we're on YouTube now with the video feed, which some of you are watching. You can check us out on YouTube. It's Masters of Engineering. Love hearing what you think. So make sure you leave a review of this episode. Tell me what you think. And you can follow me on Twitter I'm at Jay Hirschtick, JHIRSCHTICK. That's it for today. See you next time on Masters of Engineering.